Welcome and thank you for always joining us in our discussions. We are going through Form 4 chemistry under the topic metals. Specifically, we look at the extraction of sodium metal. Sodium metal is a metal that lies in the upper part of the reactivity series, and therefore we extract sodium metal by electrolysis method. Before we look at the extraction, let us start by looking at the chief ore for the extraction of sodium. And the chief ore for the extraction of sodium is known as rock salt. And rock salt is simply fused sodium chloride. The chief ore, it is that ore or rock that contains the metal in plenty. Apart from the chief ore, we also have other alternative ores which are used in case we don't have the chief ore, and one of them is the Chile salt, and the Chile salt is simply sodium nitrate. Apart from Chile salt, we can also extract sodium metal from trona. Trona is a double salt of sodium carbonate, sodium hydrogen carbonate, and this has two waters of crystallization. Those are the two other alternative ores that can be used in the extraction of sodium metal. The apparatus we use to extract sodium metal is known as the down cell, and as you can see, we have the diagram showing the down cell. So let us move down and look at the features of the down cell. So we can say sodium is extracted from rock salt, which is sodium chloride, by electrolysis using the down cell. So let us look at the features of the down cell. The features of the down cell. Number one, we have the anode, which is made up of carbon, also known as graphite. So we can say the anode is made up of carbon and not steel. Steel is iron. So there is a reason why the anode is made up of carbon and not steel. In this case, we can give out the reason. And the reason is the chlorine gas that is formed during electrolysis does not react with the carbon anode. So that is the reason. We can say the carbon anode does not react with chlorine gas formed during electrolysis. That is one of the features of the down cell. Number two, if you look at the down cell, between the cathode and the anode, we have an iron gauge diaphragm, and the function of the iron gauge diaphragm is to separate the anode from the cathode. The iron gauge diaphragm separates the anode and the cathode. Why? What is the reason? Reason is to ensure that sodium and chlorine do not recombine after separation. Another thing that you need to realize is that sodium chloride is fed from the upper part of the down cell, but sodium chloride, being an ionic compound, has a very high melting point. So to reduce the melting point of sodium chloride, we add an impurity known as calcium chloride, and the calcium chloride reduces the melting point of sodium chloride from around 800 degrees to 600 degrees Celsius, so as to reduce or minimize the cost of electricity. So we can go down and say, in our point number 3, calcium chloride is added to concentrated sodium chloride, or simply rock salt, to reduce the melting point of sodium chloride from around 800 degrees Celsius to 600 degrees Celsius. And the reason why we are doing that is to so as to minimize the cost of electricity. Since electrolysis uses electricity. So when the current flows through the down cell, the sodium chloride, which is our chief ore, is decomposed into sodium ions and chloride ions. So we can say, during electrolysis, sodium chloride decomposes into, we have sodium ions and chloride ions. Sodium ions, being positively charged, will be attracted to the cathode, and the following reaction takes place at the cathode. So we have the cathode, where the cathode is negative, and the sodium ions are attracted to the cathode, where they gain electrons to form sodium metal. Sodium can either be in liquid form or in aqueous form, but since we don't have the water added, let us say it is in liquid form. This one is also in liquid form. So sodium ions move to the cathode, where they gain electrons in order to form sodium atoms. We also have chloride ions. The chloride ions will migrate to the anode, where they are supposed to lose electrons to form chlorine gas. Remember, chlorine gas contains two chloride atoms, and therefore we have to balance. And if we have two chloride atoms forming 1 mole of chlorine, they must lose a maximum of 2 electrons. So this is the reaction, or an equation for the reaction that takes place at the anode and the cathode respectively. Remember, we are adding calcium chloride. If you look at calcium chloride is also ionic, and therefore when the current flows through the cell, calcium chloride decomposes into calcium ions and chloride ions. So we can say calcium chloride also decomposes breaks into calcium ions and 2 chloride ions. But remember, chlorine will move to the anode where it will be discharged, but we have calcium here. Calcium also will migrate to the cathode, but sodium ions are preferentially discharged because they require less energy or they easily gain electrons. Therefore, calcium can also be discharged at the cathode. Calcium can also be discharged at the cathode, but the two can be separated from sodium because number one, calcium has a higher density. Calcium has a higher density than sodium, and therefore sodium floats on top of calcium and can be tapped off. Number two, calcium has a higher melting point. Calcium has a higher melting point and therefore solidifies out fast on cooling, So sometimes you can be asked a question to identify one impurity that is present in the sodium that is collected in this particular process. The impurity that can be contained where molten sodium is collected is calcium. Remember, as the process continues, sodium ions, or the concentration of sodium ions, can go down, making the concentration of calcium ions to go up, and that may make calcium to also get collected or get discharged at this particular point, but the two can always be separated from one another. So let us look at the uses. Let us look at the uses of sodium metal. Uses of sodium metal. Number one, Sodium metal or molten sodium is used. Molten sodium is used in sodium lamps. Used in sodium lamps. Use of sodium is that molten sodium and potassium is used as a coolant. In nuclear reactors. Is used as a coolant in nuclear reactors because it has a low melting point. Because it has a low melting point. Because it has a low melting point, and it's a good conductor, and is a good conductor of electricity, among other functions of sodium. Thank you for watching and welcome to this channel. And in case you are watching this for the first time, kindly take 1 second and click the subscribe button so that anytime we do a video like this, you'll automatically be notified.